Good evening student, this is the lecture number 3 on ray optics, and a topic which is going to be discussed in this particular lecture is about reflection of light, which is the first phenomena of light. Okay, here we have some important definitions about the spherical mirror. Okay, in the figure you can see first one is the concave mirror and second one is the convex mirror. Okay, so in both the cases we have some important definitions like parallel rays, center of curvature, for what is the focus, what is pole, what is parallel axis, and so on. Okay, so here we will discuss some important definitions. First one is the center of curvature. The center of curvature is what? The center of curvature of a sphere of which the spherical mirror is a part is called center of curvature, which is denoted by C. See in the figure, this will be your center of curvature in case of concave mirror and in case of convex mirror. Okay, second one is the radius of curvature. The radius of curvature of the sphere of which the mirror is a part. Okay, जिस भी स्फीयर से आपने उस मिरर को कट किया होगा, ओके, तो उसका अपना कोई एक रेडियस ऑफ कर्वेचर रहा होगा. That is the radius of curvature is this particular spherical mirror. Okay, so the radius of the curvature of the sphere of which the mirror is a part is called the radius of curvature and it is denoted by the capital R. Okay, what is the next one is the pole. What is the pole? The center point of reflecting mirror. The center point of reflecting mirror is called pole, and the distance between the pole and the center of curvature is called the radius of curvature. Okay, next one is the principal axis. An imaginary line passing through the pole. An imaginary line passing through the pole, that is called your principal axis. Okay, what is the principal focus? Principal focus, it is a point on principal axis. It is a point on principal axis where parallel beam of light after reflection either actually meets, okay, after reflection either actually meets or appears to meet in case of convex mirror. Appears to meet in case of convex mirror is called the focus. Okay, is called the primary principal focus. Okay, it is denoted by capital F. This will be your focus in case of concave mirror, and this will be your focus in case of convex mirror. Okay, next one is the aperture. The part of mirror which can be exposed to incident light is called aperture. Okay, the part of mirror which can be exposed, okay, yeah, you can see here the part of mirror which can be exposed to incident light ray, okay, is called the aperture. Okay, so these are some important points, some important definition about the spherical mirror. Next one is the image formation, how the image will form by the spherical mirror. Okay, so there are there are some important rules, out of which any two rules should be followed, okay, for locating the position images by a spherical mirror. First one is what you can see here. First point is what? Ray which are incident parallel to the principal axis always pass through the principal focus of the mirror or appears to come through the principal focus. Okay, see the first figure. The ray which are incident parallel to the principal axis, okay, always passes through the principal focus. After reflection always passes through the principal focus. Okay, in case of concave mirror, or appears to come from focus. Okay, appears to come through the focus. Okay, so this one is your first rule. Second one is what? A ray which is incident on the mirror passing through the center of curvature follow the same path after reflection. Okay, so in this diagram you can understand with the help of this diagram. Okay, A ray which is incident on the mirror passing through the center of curvature. Suppose we have a ray which is passing through the center of curvature from here. Okay, so after reflection it after reflection follow the same path. ठीक है, यहाँ पर जो भी आपका रे इंसिडेंट होने वाला है फ्रॉम द सेंटर ऑफ कर्वेचर ऑन द मिरर, तो ये सेम पाथ को फॉलो करते हुए कैसा हो जाएगा, ये रिटर्न बैक हो जाएगा इन बोथ द केसेस, इन केस ऑफ कॉन्केव मिरर एंड ऑल्सो इन केस ऑफ कॉन्वेक्स मिरर. ओके. Third one is what? A ray that passes through the principal focus goes parallel to the principal axis after reflection from the mirror. Okay. Suppose that a ray that passes through the principal focus, एक रे है आपका जो प्रिंसिपल फोकस से पास हो रहा है. ओके, सो आफ्टर रिफ्लेक्शन इट विल बिकम पैरेलल टू द प्रिंसिपल एक्सिस, जस्ट अपोजिट ऑफ द फर्स्ट रूल. ओके. Okay, so these are the rules for the image formation, and keeping these rules in our mind, we can deal with different positions of image formation. So first one is at infinity, if our object is at infinity. Okay, so if the object is at infinity, the image formation is at focus, highly diminished, real and inverted image we get. Okay, so here we have the parallel beams coming from the object which is at infinity. After reflection it passes through the focus. Okay, so we get a point image. Okay, so we get a point image at focus, highly diminished, real and inverted image. Okay, second one is if the position of an object in between infinity and center of curvature or beyond the center of curvature. Okay, so this will be your first ray which is coming parallel, incident parallel from the object to the mirror. Okay, so after reflection it passes through the focus. Next one is what? The ray which is passing through the center of curvature follows the same path. ठीक है, ये आपका सेंटर ऑफ कर्वेचर से पास होने वाला एक रे है जो क्या होगा, रिफ्लेक्शन के बाद सेम पाथ को फॉलो करते हुए रिटर्न बैक हो जाएगा. ओके, सो हियर वी हैव वन इंटरसेक्शन पॉइंट. यहाँ पे हमें क्या मिलेगा, एक इंटरसेक्शन पॉइंट मिलेगा वेयर इन बिटवीन सेंटर ऑफ कर्वेचर एंड फोकस. सो हियर वी गेट द इमेज ऑफ एन ऑब्जेक्ट. ठीक है, सो in between center of curvature and focus, smaller than object. Okay, and real and inverted image we get. Okay, next one, at the center of curvature, if we put our object at center of curvature, okay, so definitely we get the inverted image at the center of curvature. Okay, you can see in the figure at C, same size of the object, real and inverted image. Okay, next one is if object lies between focus and center of curvature. Okay, so this is our object. This is the ray incident parallel to the principal axis, after reflection passing through the focus, principal focus, and the ray which is which is coming through the focus. Okay, after reflection क्या होगा, ये पैरेलल हो जाएगा प्रिंसिपल एक्सिस के. सो हियर वी हैव वन इंटरसेक्शन पॉइंट. ओके, तो यहाँ पे आपको क्या मिलेगा, एक इमेज फॉर्मेशन होगा इन बिटवीन इन्फिनिटी एंड सेंटर ऑफ कर्वेचर. ओके, सो क्लियरली यू कैन सी दैट we get the magnified image. Okay, here we have magnified image, real and inverted image. Okay, so in between infinity and center of curvature, magnified, real and inverted image will be obtained. Okay. Okay, next one, if I put my object at the focus. Okay, so what happened, we get image of that particular object at infinity, highly enlarged real and inverted image. Okay, these lines shows that the image will be formed at infinity. Okay, next one is the, if I put my object in between pole and principal focus. Okay, so this will be your this will be your object AB. The ray which is incident parallel to the principal axis after reflection passing through the principal focus, and the ray which is incident on through the center of curvature, return back following the same path. Okay, if I extend these two rays behind the mirror, so here we get one intersection point where image will be formed. Okay, so this will be your image. Okay, behind the mirror we get the image behind the mirror, enlarged, virtual and erect image. Okay, so these are the image formation through the through the concave mirror. Okay, next one is for the convex mirror. Okay, here we have only two conditions. First one, if my object is at infinity, and next one in between infinity and the pole. Okay, so if the image is at infinity, all the rays which are incident parallel to the principal axis, so here we have our principal focus. So these rays are appear coming from the principal focus. Okay, so our image formation is at focus behind the mirror. Okay, here we have our image. Okay, behind the mirror, very small point image, virtual and erect. Okay, and if we put our object in between pole and infinity, so we get our image in between the focus and the pole. Okay, which is smaller than object, also virtual and erect image. Okay, so this is your object, the parallel ray and the incident ray parallel to the principal axis after reflection passing through the focus. This will be your focus. Okay, the ray which is passing through the center of curvature, return back following the same path. Okay, so this will be your intersection point. So here we get our image. Okay, in between focus and the pole, smaller than object, virtual and erect. Okay, okay students, now we are going to discuss our very important derivation, which is the mirror formula. Mirror formula is a relation between focal length of the mirror and distance of object and image from the mirror. Okay, here we have consider one condition in which our object lies beyond the center of curvature. Okay, so beyond the center of curvature, we get our image in between center of curvature and focus, is smaller than object, real and inverted image. Okay, so here we have considered our object AB, though, so this is your incident ray which is parallel to the principal axis. Okay, passing through the focus, principal focus after reflection, and the ray which is incident through the center of curvature, return back following the same path. So this will be your intersection point. So here we get our image. Okay, the ray which is incident by making some angle with the pole. Okay, so this will be your incident ray which is making some angle with the pole. Okay, so this is your angle of incidence. सो सेम एंगल को बनाते हुए, सेम एंगल फॉलो करते हुए वो क्या हो जाएगा, रिफ्लेक्ट हो जाएगा सेम पॉइंट से. ओके, ए डैश. ओके, सो ए डैश बी डैश इज योर इमेज, एंड इफ आई जॉइंट पॉइंट सी through point E, so this will be your normal. Okay, this will be your normal. This line is perpendicular to the mirror surface. Okay, So this is your incident ray, this is your reflected ray, this will be your normal. Okay, so this is the angle of incidence and this is the angle of reflection. Okay, so in above figure the ray diagram is considering three rays for image formation by a concave mirror. In the figure, here we have two triangles. First one is the triangle A dash B dash F. Okay, this will be your first triangle, and second one is N E F. Here we have two triangles. This one is your first and this will be your second. Okay, both are similar triangles. So by the basic proportionality theorem we have A dash B dash upon NE equals to A dash F upon NF. Okay, as the aperture of the concave mirror is small and the point N and P, okay, point N and P are very close to each other, this and this very close to each other, then what happened? NF is approximately equals to PF, NF is approximately equals to PF, okay, and NE is approximately equals to AB, NE is approximately equals to AB, this. Okay, so we have the relation A dash B dash upon AB equals to A dash F upon PF. Okay, since all the distances are measured from the pole, we have, okay, since all the distances are taken from the pole, so we have A dash F. What is your A dash F? This is your A dash F. Okay, A dash F is nothing but P A dash minus PF. Okay, next one, A dash B dash upon AB equals to P A dash minus PF upon PF. Okay, so put the value of A dash F in the previous equation which we have. This will be your first equation, A dash B dash upon AB equals to A dash F upon PF. So here we have equation number 1, A dash B dash upon AB equals to PA dash minus PF upon PF. Okay, also in triangle ABP, see the figure, triangle ABP, and next one is A dash B dash P, A dash B dash P. This these two triangles we have. Okay, both are similar triangles. So A dash B dash upon AB equals to what? PA dash upon PA dash upon, okay, A dash B dash upon AB equals to what? PA dash upon PA. Okay, this will be your PA and this will be your PA dash. Okay, from equation 1 and 2 put the value of A dash B dash upon AB. Okay, so we get PA dash, this relation, PA dash minus PF upon PF equals to PA dash upon PA. This will be your equation number 3. Now applying the Cartesian sign convention, PA is what? So PA is your distance of object from the pole which is taking negative. Okay, that is minus U. Distance of object is measured against the incident ray. Okay, you have studied the rules of sign convention already, okay, in lecture number 2, so no need to confused here. Second one is PA dash equals to minus V, that is the image distance. See the figure, PA dash is the distance of an image, okay, from the pole. PF PF is nothing but your focal length of concave mirror is measured against in the incident ray. Substituting this value in equation number third, this is your equation number third, PA dash minus PF upon PF equals to PA dash upon PA. So we get, on substituting the value, minus V minus of minus F divided by minus F equals to minus V upon minus U. So it becomes what? V minus F upon F equals to V upon U, or separating the denominator, so we get V upon F minus F upon F equals to V upon U. Finally we get V minus F minus V upon F minus 1 equals to V upon U. Okay, on dividing both side by V, we get 1 upon F upon 1 upon F minus 1 upon V equals to 1 upon U, or 1 upon F equals to 1 upon U plus 1 upon V. This is called the mirror equation, the very important equation. Some of the numerical can asked from this particular formula. Okay, now we have relation between U, V and R. What is the relation between F and R? F equals to R upon 2. Okay, so put in the mirror equation, 1 upon U plus 1 upon V equals to 1 upon R upon 2. So finally we get 1 upon U plus 1 upon V equals to 2 upon R. Okay, so this will be your final equation. Okay, so this is the end of first lecture. Okay, the question which arise in your mind, you can ask in the WhatsApp group. Okay, or you can write in the comment box also. Okay, thank you so much.